Hello everyone, I am Shaurya Chaudhary from Zogla Incorporated. I am a software engineer at Zogla Incorporated. We provide REST APIs for telephony services. Today I am going to talk about chatbots, simple chatbots which we can code using. Chatbots are really simple. There are basically 4 modules that are needed for a chatbot. First, we need to connect to a chatbot API, whether it be Facebook or Slack or WhatsApp, web, anything. And the second part is parsing the messages the user sends. We can do it using Parsley or with AI or just do simple parsing as well. The third thing we need to do is process the messages and do some action. This is basically the business logic, and then respond to the user. So the architecture is something like this. Catching the messages can be via polling. It can be event driven. We can parse the message, do an action and respond. So I'll show this is a Slack bot. So I started the Slack bot. I'll send a message to the Slack bot. So I'm just polling over here, and as you can see, it has polled the message, and I'm receiving a message call after I send the message to the Slack bot from my mom, basically, which because of the caller ID I set. Okay, so I'll show the code, run through the code once. Like I said, there are 4 stages. So the first stage is basically to catch the messages. So I'm just polling over here using a while loop. The second stage is the initial parsing, the parsing which I'm doing. And then after the parsing, I'm sending it to this method, which is
30 seconds.
Which is which is just passing the message and doing an action. And after the action, I'm just responding. So this was about it. So if you want the code, you can go to my github.com xuryax pyconph 2018. Thank you. I was Shaurya Chaudhary from Zogla Incorporated.
This afternoon I will be presenting my project, which is Alexa Pi. So it is a Raspberry Pi powered Amazon Alexa with face recognition and motion tracking. So the idea of this project is only the librarian can activate Alexa. So with the use of face recognition, it will recognize the face of the librarian. Then it enables Alexa. And it has also a motion tracking, which is I use pan and tilt with 2 servos, and here is the video. So it tracks the motion of the student or the librarian. And then here is the picture of adding data set, then recognizing the librarian. So, okay, so these are the other menus, the user profile, adding of data, so display data, then train the model. So I use local binary pattern, and this menu is for enabling Alexa. And it has also a home assistant. So if you want to switch on and off light, the bedroom lights, the comfort room, and it has also a video call. So for example, if the student or Alexa cannot answer a certain question from the student, it will redirectly communicate the librarian through a video call, so local. And then the last part is the chat. So I am planning to put a chatbot. I guess that's all.
Yeah, my name is Ted Matthew de la Cruz, former software engineer of freelancer.com, former software engineer of Yoyo Holdings Philippines, and currently unemployed for more than 1 month. I want to talk about Wagtail CMS, nothing special. Alright, so this is Wagtail. Check out wagtail.io. It's free, beautiful, versatile, and it's fast. Alright, so let's check out the directory structure. So it looks like it's based on Django, so if you love Django, you should love Wagtail CMS. say, check out the models. So this is the home page, and it looks like this. So this is the initial default site index page of Wagtail, and then in the admin page, it's just home title. All right, so say you want to add a header and a text field to the home page. I just copy and paste this. For the header, you can see that I use a simple Django car field here, rich text field from Wagtail, and then you register those fields to the field panels, content panels here, so that you can see it in the admin page. But I have to migrate that first. Make migrations. Alright, so you should see these fields in the admin page. Alright, so test. Test. Text. Alright, so publish. And there. But we should update the HTML template so that we can show these fields, header and text, and indicate that it's a rich text field. So if you check out the home page, you can see those fields. So it's very simple, that's it. And I'm currently migrating my website, static website from to Wagtail CMS. And it's nothing special, blah, blah, blah. I have blank fields here, so check out the admin page. I have the skills. So you can see I have the skills section blank. Let's add some skills. I can crack index with 1. Alright, so publish. Alright, simple as that. Yeah, nothing special. If you like Django and then you're looking for a very simple CMS, check out Wagtail CMS. That's it. Thank you.
I'm Takashi, CTO of Hakarus, which is AI and healthcare venture startup in Japan. So I come from Kyoto. I'm not sure how many guys have experience to travel here, but Kyoto is one of the oldest cities in Japan, and you can see this kind of temple and shrine and any other old stuff there. So I'd like to talk about some shiny things like this temple today. So that is sparse modeling. I think sparse modeling is less popular than deep learning or any other machine learning method, but this is very powerful if you don't have not so many large amount of data, or if you really want to know the, the feature of your input data or something like that. So sparse modeling itself is not concrete, but the general approach for data analysis. And what sparse or sparsity means is that the most of data, input data is 0. So by this assumption, sparsity to the data, we can see some interesting advantages in using this method. These are the major advantage here. The one of them are the feature selection. I'd like to show the brief example of this later on. And also the other advantage is this method will work with even small amount of data. So here is the one example of our project. Applying the sparse modeling to the image analysis, you can extract or detect some characteristic part of image. So using this feature, we use this feature to detect some damaged part of the wall of the image taken by drone. Now, what what is interesting of this project is that we did build this model from just same image. You don't have to prepare tens of thousands of images to build machine learning model. Just one image is enough. Then let me show a brief example of feature selection. So here is the polynomial regression issue. So the truth, that data, observed data looks like this, and this data comes from the equation at the bottom of this. So here is the goal of this is to estimate of the 80 parameters of this equation. We don't know this equation at all. So we need to estimate the parameter. So at first, we usually start with simple linear regression, like this. But the result looks like this. It's overfitting. Because of the existence of noise, the simple linear regression model doesn't work. And the result of parameter looks like this. So actually, there are several parameters, the value of which is very big, like over 150, or very small, like minus 200 or something like that. So the result doesn't explain the model at all. Then, when we apply the sparse modeling approach to this simple regression model, the result looks like this. It's really great. And the parameter, estimated parameter looks like this. It's much better, and the total value, the absolute value of each weight is less than the 1. So this really explains the model very well. And I should say something. And this model we use is named Lasso. This is one of the very famous approach of sparse modeling. And the other approach named orthogonal matching pursuit. It's a bit hard to pronounce, but we usually use called this OMP. And this is other approach to compute this kind of things. Okay, then as you can see, here is the Python code to run these three models I mentioned. We already have GLASS or OMP in scikit-learn, so you don't have to implement it from scratch. So this is the quite same story Erika mentioned yesterday. You just need a few lines of code. So there are several algebra behind the algorithms, but let me skip this due to the time. The summary looks like this. So you can start with sparse modeling with using scikit-learn. But sorry, I'd like to say some important thing. I'm joining the local user group in Kyoto. This takes place third Friday every month. So if you have a chance to come to Japan, come visit us. Thank you.